Hello and welcome back to another trick here, A-Level Further Maths exam question. So we're on question 5 here in our series. And again, we're going to take a look at another Core Pure question. Now, before I get started with today's question here, as always, if you're looking for even more A-Level Further Maths revision, be sure to visit our website, AJMaths.co.uk. We have extra worksheets, extra revision videos, and even mock exam papers to help boost your revision and your grade. Perfect. I nailed my introduction. Let's get started then with today's question here. So what do we have then for this question here? Well, for this question then, all we want to do here is just use a hyperbolic substitution and a little bit of calculus here to show that this integral here is equal to this result here, right? Where k is just an arbitrary constant. So when it says that k is an arbitrary constant, it's just saying that k is our constant of integration, right? Now, where do we begin then with this question here? Well, given that we're going to use a hyperbolic substitution here, it would seem sensible to actually start by choosing and defining our hyperbolic substitution here, right? Without that, well, we're not going to get very far, right? So what I'm going to do here is I'm going to let x, so let x here equal to cosh u, okay? Now, first things first then, why am I choosing this here as my substitution, right? Because normally for questions like this, they will give you the substitution. However, for this question here, they don't, right? That's up to us to choose. So why am I choosing this here as my substitution? Well, the reason for that then is because if I refer back to this result here, result that we want to obtain, they have cosh x, right? So I know then that at some point here, I will need to take the inverse here. So our cosh then of both sides here, right? So it would seem sensible then to choose this here, x equals cosh u, as my substitution, right? So what else do we also require here? Well, I need something for x squared. I need something for the denominator here, so the square root of x squared minus 1, and also something for dx, right? Once we obtain each one of those, we can just simply rewrite this integrand here. So let's just start with dx then. So if I've got x equals cosh u, I can obtain dx by du by differentiating x with respect to u, right? So dx by du here. So dx by du, hopefully nice and straightforward here. If we've got cosh u and I differentiate cosh u with respect to u, I simply get sin u, right? So we get sin u there. And what I can now do here is just break all the laws and rules of mathematics and essentially just treat this derivative here as a fraction. We shouldn't really be doing that, but it's just what we do. Why not? So therefore, in that case, then dx here is simply sin u du, right? So sin u du. Perfect, good stuff. That's the first thing that we require here. That is dx, right? Now for x squared then, well, if x equals cosh u, x squared is just simply the square of both sides, right? So again, nice and easy. In that case then, x squared here. So x squared here is just simply cosh squared u, right? We get cosh squared u there, just like that. And then what about the square root here of x squared minus 1? So again, let's just do this underneath here. So the square root then of x squared minus 1. Well, if x squared here is equal to cosh squared u, then the square root of this here, so the square root then of x squared, so that is cosh squared u, we have the square root then of cosh squared u minus 1, okay? Now on its own here, this is useless. That does not help me at all. However, what you should hopefully recognize here is that cosh squared u minus 1 is sin squared u, right? It's one of our trig identities here. So in that case, then I take the square root of this here. It's the same as taking the square root of sin squared u. And in that case, then we just simply get sin u. Perfect. Okay. So what I've got here then is everything that I need to now rewrite this integral here. So let's just do that underneath them. So we'll do that here. So we can now rewrite this integral here by using the appropriate substitutions given on the right-hand side here. So what I've got then is the integral here of x squared. So x squared then is just cosh squared u, right? So I've got cosh squared u here. So cosh squared u. That's all over the square root then of x squared minus 1, which is just simply sin u here. So I've got cosh squared u over sin u. And then we have dx here. But dx then is just simply sin u du. So putting that all together then, We times this by sine u du, just like that. There's no limits to contend with here because the original integral had no limits, right? So that's not something that we do need to worry about for this problem. However, for similar problems here, if you did have limits on the original integral, then that is something that you do need to kind of worry about and actually convert. But like I said, for this problem here, not an issue that I need to kind of worry about, right? So let's just continue then. So what can I do here? Well, I've got a sine u here. That just cancels with this sine u here, right? And in that case, then what I get here is the integral of cos squared u du. So cos squared u du. Okay. Now, this integral here, unfortunately, I can't just go straight into kind of integrating that. That's not something that I can just integrate on the spot. However, what I can do here is use our trig identities, right? Now, I don't know the identity here for cos squared u off the top of my head. I wish I did, but off the top of my head, I don't. However, what I can do here is just use Osborne's rule, right? Now, hopefully you are familiar with Osborne's rule. If you're not, just go watch our previous video where we've covered this in quite a bit of detail. So it's in our hyperbolic functions chapter. I think it was like video 4 off the top of my head. But I'll leave a link to it in the description down below as well. But basically, what Osborne's rule allows us to do here is easily convert them between the trig identities that we first learned in A-level maths, and we can kind of convert that to its respective hyperbolic identity. Okay, so cos squared u, as I've just said, I don't know that off the top of my head. However, I do know then that cos squared u here, let's just do that over here then. So cos squared u, that is 1 over 2. So 1 over 2 cos 2u plus 1 over 2, right? And then by Osborne's rule here, I know then that cos squared u here will simply be 1 over 2. I get 1 over 2 cos 2u. So cos 2u plus 1 over 2, right? So we've adapted it here then to its respective hyperbolic trig function, and we obtain this here. So we can now replace the integrand here with its appropriate trig identity. So I've got the integral here then. So the integral here then of cos squared u, which is 1 over 2 cos 2u plus 1 over 2. Let's put all of that inside brackets. I can't speak. So 1 over 2 cos 2u. So 1 over 2 cos 2u plus 1 over 2, just like this, right? And we're integrating here then with respect to u. Perfect. Let's just keep going here. Now, at this point, the thing that we're looking to integrate, so the integrand, right, is a lot easier to work with. So I can just go term by term here, right, integrating with respect to u. So 1 over 2 cos 2u, so I'm going to divide by 2 here. That's going to give me 1 over 4, and then the cos 2u will integrate to give me sine 2u. So altogether then, what I get here is 1 over 4. So 1 over 4 sine 2u, just like that. I then get the 1 over 2 here, so integrating with respect to u then, that gives me 1 over 2 u, right? So 1 over 2 u, just like that. And then just be very, very careful here, right? We don't have any limits to contend with here for this integral. So in that case, then we do need our constant of integration. Normally, and kind of like generally speaking, we just, put a plus c there. However, for this problem, they've used plus k. So I will keep it consistent. I'll also use plus k here. Okay. Perfect. Now, where do we go from here then? So again, what I can do here is just use Osborne's rule then, because this sine 2u here isn't particularly useful, right? However, by using Osborne's rule here, I know then that sine 2u, so sine 2u here, that is simply 2 sine u cos u. Okay. And in that case, then we can adapt this here by using Osborne's rule. And in that case, then sine 2u is equal to 2 sine u cos u. Just like that. So what I've got here then is 1 over 4. So 1 over 4. I've got 2 sine u cos u. So just replacing sine 2u with this here, right? So 1 over 4 times 2 sine u cos u, just like this. I've got 1 over 2u, so plus 1 over 2u, and plus k. Perfect. So up to now, all looking good. What I can see here then is for the final result, they have a 1 over 2 on the outside, so they factor out a 1 over 2 here. So I'm going to do the same. I'm going to apply a factor of 1 over 2, right? So if I do that then, what would I get here? So multiplying through here, I get 2 over 4, so that's 1 over 2. So put out the 1 over 2 here. We get 1 over 2 then, bracket. So this is sine u cos u here, right? Because 1 over 4 times 2 is 2 over 4, so that's 1 over 2. But I've pulled out the factor of 1 over 2, so I just get sine u cos u. So sine u cos u, just like that. The 1 over 2, we pull that out as a factor, so I just get plus u there. So plus u and plus k. Perfect, we're nearly there now, guys. Let's just keep going. So where can we go from here? So notice they've got x and the square root of x squared minus 1. They've just got r cos x here. I've got things in terms of u here. So basically at this point here, let's just kind of reverse substitute here. And hopefully we should arrive at this conclusion here. So what do we get here then? So sine u is, what is sine u? So sine u here, as we've obtained at this point here, is the square root of x squared minus 1. So what I've got here is 1 over 2. And really, I should have put square brackets here at this point. Sorry, so this is slightly incorrect. Let me just quickly amend that just so it's not a major point, but I'll quickly amend it. Just to be precise then. Like that, right? So if I continue then, sine u is, as we've just mentioned, the square root of x squared minus 1. So I've got 1 over 2 times sine u, which is this here, times by cos u, which is x, right, from the original substitution. So I've got x times by the square root then of x squared minus 1. So we times it by the square root of x squared minus 1, just like that. I've got plus u here. Now, x equals cos u. How do we obtain u here? Well, as I mentioned at the very beginning of this video here, right, when we were choosing our substitution, I do need to take the inverse here, or r cos of both sides, right? So in that case then, u here is r cos x. Okay, just taking r cos of both sides here. So plus u then is just plus r cos x, right? So plus r cos x. Just like that. Close those square brackets and don't forget your plus k as well. And there we go then. So as required, proof complete, QED, whatever else you want to put there. But there we go then. Perfect. Good stuff. So there we have it then, guys. Hopefully that wasn't too bad. What are we on? Just over 30 minutes here. So definitely a little bit easier than some of the previous questions that we've already seen here within the series. But there we go then. Again, as always, if you are looking for any further revision here for A-level further maths, just check out our website, ajmaths.co.uk. And if you made it to the very end of this video, thank you so much. You are a legend. Thank you for watching.